Hi friends, this is a continuation of the chapter index number. In today's session, we'll be discussing about various methods of constructing index number and test for index number, then bias in an index number. Okay, let us start with the various methods of constructing index number. Now, index numbers can be classified into two groups, simple or unweighted index number. The second one is weighted index numbers. Now these are simple and weighted index numbers are further divided as a simple aggregative index number and simple average of price relative. That is under unweighted index number. Unweighted is also called as simple index number. Now under weighted index number, we have weighted aggregative index number and weighted average of relatives index number. Okay. Now the difference between simple and weighted index number or unweighted and weighted index number is that in simple index number, we give equal importance to all the items. Whereas in weighted index number, depending on the importance of items, we give the weightage. For example, we know that rice is more important than sugar. Therefore, rice should be given more weightage than the sugar. Okay? Based on the consumption, weightages are given. Based on the quantity consumed, weightages are given. Okay. Now we shall consider this one by one. The first one is unweighted or simple price index number. Okay, as I told you, under unweighted we have simple aggregative and the other one is simple average of price relative. Okay, the first one here, simple aggregative method. The formula is price index number P01 is equal to summation P1 divided by summation P0 into 100. What you have to do is find the total of the prices in the current period, that is in the numerator, and in the denominator sum of the prices in the base year into 1000. Or in other words, it is the aggregate of the prices of all the commodities in the current period expressed as a percentage of the aggregate of the prices in the base period. Okay. Now the formula is summation P1 by summation P0 into 100. That is simple aggregative method. Okay. I'll repeat again. In simple aggregative method, the formula is very simple. It is summation P1 divided by summation P0 into 100. Where P1 is nothing but prices in the current period. P0 is prices in the base period. Okay, you have to sum the prices of the items in the current period, then divide it by sum of the prices in the base period, then multiply it by 100. So that is simple aggregative price index number. Now, simple average of price relatives method. Now here, average of price relative. We are taking the average of the price relatives. The average may be arithmetic mean or geometric mean that we have discussed already. Okay. Now, the unweighted arithmetic mean price index number is given by summation P divided by N, where P is nothing but a P1 divided by P0 into 100. That is the price relative. N is the total number of items considered. If you have considered 5 items, then N is equal to 5. So first you have to find P1 by P0 into 100 individually for these 5 items. Then add it. Okay. The second one here, the unweighted or simple geometric mean index number. That is given by anti-log of summation log P divided by N. Last year under geometric mean topic, we have discussed how to find the log of a number. So here what you have to do is first find P. What is P? P is equal to P1 divided by P0 into 100. Then find log of P. Okay. Then add that column. Add log of P column. Then to the total of log of P, you have to divide it by N. The same way we have found a geometric mean last year. Okay. Next, weighted price index numbers. Okay. In weighted price index numbers, there are two methods. Weighted aggregative price index numbers and weighted average of price relatives. Okay. Now, first, weighted aggregative price index number. Now, in weighted aggregative price index number, there are 6 different formulas. The first one is Laspier's price index number. Second one, Pasch's price index number. Third one, Marshall-Edwards price index number. Fourth one, Darvish-Bowley price index number. Fifth one, Fisher's price index number. Sixth one, Kelly's price index number or a fixed weight index number. Okay, let us know the formula of these one after the other. Okay, the first one, Laspier's price index number. Now here, weight is nothing but the base year quantities. Here, base year quantities are considered as the weight. Now, we already discussed weighted index number is nothing but where the items will be given the weights depending upon its consumption. Now here, base year quantities are used as weight. You can see here in the formula Q0 in the numerator and Q0 in the denominator. Now the Laspier's formula is summation P1 Q0 divided by summation P0 Q0 into 100, where P1 is the current year price, P0 is the base year price, Q0 is the base year quantity. Okay, next one, Pasch's price index number. In Pasch's price index number, current year quantities are used as a weights. Here the formula is summation P1 Q1 divided by summation P0 Q1 into 100, where Q1 is the quantities used in the current year. So, current year quantities are used as weight in case of Pasch's price index number. Okay. Next one is Marshall-Edwards price index number. Here, the average of base year and current year quantity is taken as the weight. That you can see in the bracket. You have Q0 plus Q1 divided by 2 in both numerator and denominator. Okay. Now, the formula is summation P1 into Q0 plus Q1 divided by 2 divided by summation P0 into Q0 plus Q1 divided by 2 into 100. Okay, which can further simplify to the form summation P1 Q0 plus summation P1 Q1 divided by summation P0 Q0 plus summation P0 Q1 into 100. This is Marshall-Edwards price index number. Okay, next, Darvish-Bowley price index number. Darvish-Bowley is connected to Laspier and Pasch's by the relation Darvish-Bowley is equal to Laspier's plus Pasch's divided by 2. That means Darvish-Bowley index number is nothing but the arithmetic mean of Laspier's and Pasch's price index number. So Darvish-Bowley is a L plus P divided by 2. Simply we can say L plus P divided by 2. That is Laspier's plus Pasch's divided by 2. Okay. Now if you simplify the formula, you will get the formula as a half into summation. Okay, that is Laspier's price index number plus Pasch's price index number, that is equal to half into summation P1 Q0 divided by summation P0 Q0 plus summation P1 Q1 divided by summation P0 Q1 into 100. So in case of Darvish-Bowley, we can't relate the base year and current year quantities. We can say here the weight attached are the combination of base year and current year quantities. Okay. Now, Fisher's price index number. The fifth one is Fisher's price index number. Okay. In Fisher's price index number is the geometric mean of Laspier's and Pasch's price index number. Therefore, Fisher is equal to square root of Laspier into Pasch's, or simply It is square root of L into P. Okay, if you substitute, it is square root of summation P1 Q0 divided by summation P0 Q0 into summation P1 Q1 divided by summation P0 Q1 and into 100. And that 100 is outside the square root. Okay, now Kelly's price index or fixed weight index. Here the formula is summation P1Q divided by summation P0Q into 100. Here Q denotes the fixed quantity for both base and current periods. So the quantity is fixed here. It can be the quantity like the average of base year or current year, or it can be quantity of any other period. Okay. Now here in weighted average of price relative, we can either use geometric mean or arithmetic mean. If arithmetic mean is used as the average, then price index number P01 is equal to summation PW divided by summation W, or summation WP divided by summation W, where W is the weight, P is the price relative. Okay. Now weighted geometric mean index number is P01 is equal to antilog of summation W log P divided by summation W. What you have to do is, first find P. You will be given P1 and P0. What is P1? P1 is current year price. P0 is base year price. That will be given to you. You have to find capital P. Capital P is P1 by P0 into 100. Okay, after that you have to find log of capital P. Then you have to multiply log of P column to W column. W will be given to you. So W into log of P. That column you have to find. Finally you sum the column W into log of P. Okay, now add the weight. Find the total weight. Now the formula antilog of summation W log P divided by summation W. So substitute the sums and finally you will get the answer. Okay. Now, Fisher index number is called as an ideal index number. The reason is, it is based on geometric mean, which is considered as an appropriate average for averaging ratios. We have learnt last year, whenever you have rates or ratios, geometric mean is the appropriate measure of averaging. Since Fisher index number is nothing but the geometric mean of Laspier's and Pascher's, it is an appropriate average or an appropriate index number. Okay. Second one, it takes into account both current year and base year quantities. Laspier's is based only on Q0. Pascher's is based on Q1. But Fisher is based on both the Q0 and Q1. Why an index number should be based on Q0 and Q1, we will discuss next under the topic bias in an index number. Third one, it satisfies both the TRT and FRT. TRT, time reversal test. FRT, factor reversal test. Okay, we will be discussing about TRT and FRT after few minutes. Okay. Fourth one is, it is free of bias. Bias we have not yet discussed. We'll be discussing about bias. That time we will come to know how Fisher index number is free of bias. Okay. Now there are 4 reasons why Fisher index is called as an ideal index number. The first one, it is based on geometric mean, which is considered as an appropriate average for averaging ratios. Second one, it takes into account both current year and base year quantities. Third one, it satisfies both TRT and FRT. Fourth one, it is free of bias. Okay, this question will appear for 2 marks. You can write any 2 of this. Okay. Now, next, test for adequacy of index number. Now, we discussed about several index number formulas. Now, out of these, we have to decide the best one, the ideal one. Now, to decide which is the ideal index number, there are several tests suggested. They are, first one, unit test. Second one, time reversal test, which is written as TRT. Factor reversal test, written as FRT. Then the fourth one is circular test. if our index number satisfies most of this, that can be considered as an ideal index number or best index number. Okay, now what is unit test? Unit test requires that the index number should be independent of the units in which a price or quantities of various commodities are quoted. That means index number formula should be a pure number. There should not be any units of measurement. Like whenever you find average height, it will be like average height of students is 154 centimeter. So it is depending on the units of measurement, that centimeter, 154 centimeter. But whenever we find index number, it is a pure number. For example, index number for the current period is 125. So there is no unit of measurement. There is no unit of price. There is no unit of quantity. Okay, so index number formula should be such that it should be independent of the units in which prices or quantities are measured. Okay, now this unit test is satisfied by all the index number, but it is not satisfied by simple aggregative price index number formula. Simple aggregative price index number, just recall that. Simple aggregative price index number is summation P1 divided by summation P0. So you are adding the price in the current period in the numerator. So some items have the units of measurement like rupees per kg. Some have rupees per liter. Some rupees per meter. We can't add all these things. We can't add the units which are measured in different units of measurement. So simple aggregative price index formula is depending on the units of measurement. So unit test is satisfied by all the index number formula except the simple aggregative price index formula. Okay, now time reversal test requires that index number computed backward should be the reciprocal of the index number computed forward, except for the constant of proportionality. But here P10 is equal to 1 by P01. The TRT, the time reversal test requires a P10, index number computed backwards, that should be is equal to 1 divided by P01, reciprocal. So P01 means it is the price index number with the base 0 and current period 1. P10 is the price index number with the base 1, current period 0. Just interchanging the base year and current period. If we interchange the base year and current period, then index number computed backward should be the reciprocal of the index number computed forward. Or simply P01 into P10 should be is equal to 1. P01 is with the base year 0. P10 is with the base year 1. Okay, this is what is time reversal test. Time reversal test is not satisfied by Laspier's, Pache's and Dorbish-Bowley index number, but it is satisfied by Marshall, Edwards, Fisher's and Kelly's index number. So there are three index number which satisfies a TRT. Marshall, Edwards satisfies TRT, Fisher satisfies and Kelly's also satisfies TRT. Okay. Next one is a factor reversal test. This test requires that product of the price index and quantity index should be equal to the corresponding value index. That is, P01 into Q01 should be is equal to V01, where V01 is nothing but value index number, Q01 is quantity index number, P01 is price index number. V01 formula is summation P1 Q1 divided by summation P0 Q0. Okay. FRT is satisfied by Fisher index number and no other index number formula. Fisher index number satisfies FRT and no other index number formula satisfies a FRT. Okay. Now, the fourth one is circular test. Circular test is the extension of time reversal test for more than 2 periods and is based on the shiftability of the time period. That is, P01 into P12 into P20, that's equal to 1. So we are considering 3 periods here, 0, 1, 2. Now it works in the circular manner like 0, 1, 2. P01, P12, then P20 back to the origin. That should be equal to 1. This test is satisfied only by the simple geometric mean price index number and kill is fixed beta index number. Okay. Now, what is bias in an index number? While discussing about why Fisher index number is called as an ideal index number, I told one of the reason is Fisher index number is free of bias. But what is bias? Okay. Now, we know that it is a common truth that as the price of the commodities increases, its consumption decreases. Right. Okay. That means if Q0 is a base year quantity, it will not remain Q0 in the current period. It will change to some other number. It will reduce to some other number. Okay. If price of the commodities increases, its consumption decreases. If Q0 is the quantities consumed in the base year, then as the price increases, its consumption decreases. That means Q0 will reduce to some other number. Okay. Now, in last year's price index number, we are taking Q0 as the weight. You can recall the formula. Last year's price index number is equal to summation P1 Q0 divided by summation P0 Q0 into 100. Okay. In the numerator, you have Q0 and price is P1. I told you Q0 will reduce to some other number. But in last year's index number, since base year quantities are considered as the weight, so it will give an answer which is slightly greater than what is actually happening in reality. Okay, that means last year's index number is an estimate of the actual situation. So, last year's index number shows an upward bias because in the numerator, actually it is not Q0. It is a number which is slightly lesser than Q0. But last year's index number takes it as Q0. Therefore, it is giving an answer which is slightly greater than what is actually happening in reality. So, last year's index number shows a upward bias. Now, okay, as the price of the commodities increases, its consumption decreases. But whether the need of the commodities decreases? No. The need is the same. Need will remain the same. For example, a family requires 1 kg of rice per day. But if the price of rice increases, they may reduce it to 3/4 kg. They are reducing it to 3/4 kg because it is not affordable for them. But their need is same. Their need is 1 kg. Need has not reduced. They have reduced it. Okay. Now what happens? In case of Pashe's index number, since they could not afford the price, they are reducing it to Q1. But in the current period, their need is not Q1. It is slightly greater than Q1. But Pashe's takes it as Q1. It takes, for example, they will take it as 3/4 kg. But their need is 1 kg. Therefore, Pashe's index number gives an answer which is slightly less than the actual one. Actually, we need a slightly more than what is Pashe's finds. Okay, so Pashe's index number shows a downward bias. It underestimates the index number. Okay, so last year's index number shows a upward bias. Pashe's index number shows a downward bias because it is using current year quantity as the weight, Q1 as the weight. Okay, then Fisher, Darvish and Marshall-Edwards is based on both base year and current year quantities, and therefore they are free of bias. Okay, because that upward and downward bias will be cancelled out. So, Fisher's, Darvish, Bowley and Marshall-Edwards index numbers are free of bias. Okay, now this is about the different methods of finding index number. Then we discussed about test for index number, and we came to know that Fisher index number satisfies most of the test. It satisfies unit test, it satisfies time reversal test, it satisfies factor reversal test, but it does not satisfy the circular test. But out of the four, the three tests are satisfied by only Fisher index number. Therefore, Fisher index number is called as an ideal index number. Then next, we discussed about the bias in an index number. Okay, now this is about index number, its method, different methods, test and bias. Thank you.